अस्सलाम वालेकुम दोस्तों, एंट्री टेस्ट की तैयारी के हवाले से कुछ अहम सवालात आपकी खिदमत में हाज़िर हैं। अगर आप इंजीनियरिंग यूनिवर्सिटी यूईटी टेक्सला लाहौर या इंजीनियरिंग के किसी भी प्रोग्राम में एडमिशन के हवाले से एंट्री टेस्ट की तैयारी कर रहे हैं या पाकिस्तान मेडिकल एंड डेंटल काउंसिल में MBBS BDS के एंट्री टेस्ट के हवाले से MDCAT या ECAT के हवाले से अगर आप तैयारी कर रहे हैं, उसके हवाले से ये कुछ MCQs मल्टीपल चॉइस क्वेश्चंस हैं जो कि फिज़िक्स के टॉपिक से रिलेटेड है। इन मल्टीपल चॉइस क्वेश्चन के साथ एक्सप्लेनेशन भी दी हुई है और उनको सॉल्व करने का तरीका भी दिया हुआ है। ये MCQs के हवाले से पार्ट 3 है जो आपकी खिदमत में पेश है। आई होप कि एंट्री टेस्ट में आपको इससे काफ़ी हेल्प मिलेगी। आप देख रहे हैं इनोवेशन चैनल। एजुकेशन के हवाले से, जॉब कैरियर के हवाले से हमारे चैनल को सब्सक्राइब करें। अगर अभी तक आपने सब्सक्राइब नहीं किया तो सब्सक्राइब ज़रूर करें। सब्सक्राइब करते हुए बेल के बटन को ज़रूर प्रेस करें। अपने दोस्तों के साथ भी शेयर करें। बेल के बटन को प्रेस करना इसलिए ज़रूरी है ताकि जो ही लेटेस्ट इन्फॉर्मेशन अपलोड हो फौरी तौर पे आपके पास पहुंच सके। Some important multiple choice questions related to light matter interaction are given in this presentation. Question is, a ray of light having wavelength 589 nanometer is incident on the glass slab. If the refractive index of glass is 1.52, what will be the speed of light in that glass material? Option 3 into 10 raised to power 8 meter per second, 5 into 10 raised to power 8 meter per second. Option 3 is 3.5 into 10 raised to power 8 meter per second, and option 4 is 1.97 into 10 raised to power 8 meter per second. And the correct answer is option 4, 1.97 into 10 raised to power 8 meter per second. To solve this problem, you must know that the refractive index is equal to speed of light c divided by speed of light v. C represents the speed of light in vacuum or air, whereas v is the speed of light in that material. So from this formula we can get v, speed of light in glass material, is equal to c over n. C is, we know that c is 3 into 10 raised to power 8 meter per second, whereas refractive index is 1.52. When we use this formula and calculate the speed of light in glass material, we get the answer 1.97 into 10 raised to power 8 meter per second, which is less than speed of light in air. Remember that speed of light in any material cannot be greater than the speed of light in space or air. Next question is, total internal reflection is very important optical effect. This occurs only when light is directed from a medium having dash index of refraction towards one having dash index of refraction. There are 4 options: higher than lower, lower to higher, same medium, no effect. And the correct answer is option 1, higher to lower. Remember that the total internal reflection always happens when a ray of light is incident. A ray of light is traveled from a medium having high refractive index to low refractive index. It is when light travels from denser medium to rare medium then total internal reflection takes place. All energy reflected for incident angle greater than critical angle theta c. Next question is, a ray of light passes from a material with index of refraction 1.5 into one with index of refraction 1.3. Compared to the incident ray, what happens to the refracted ray? There are 4 options. It bends away from the normal, it bends towards the normal, it moves along the normal, no effect is observed. And the correct answer is option 1, it always bends away from the normal. Remember that whenever a ray of light travel from medium having higher index of refraction to lower index of refraction, it always bends away from the normal. Next question is, index of refraction is defined as the ratio of speed of light in air to the speed of light in a material. The speed of light in any material is always less than the speed of light in air or vacuum. Three options: less than, greater than, or remain same. And the correct answer is option 1, less. It means the speed of light in any material is always less than the speed of light in air or vacuum. Next question is, refraction of light means change of path of light when encounters a boundary between two media. A ray of light traveling from rare medium to denser medium bends. Option 1, towards the normal, option 2, away from the normal, and option 3, travels straight along the normal. And the correct answer is option 1, towards the normal. Next question is, midpoint between lens surface and principal axis is termed as focal center, mid-center, option 3, focal point, and option 4, optical center. And the correct answer is option 4, optical center. Question: X-rays reflected from a crystalline material create an optical pattern that can be used to understand option 1, strength of X-rays, option 2, the structure of the solid, option 3, wavelength of X-rays, option 4, defects in the materials. And the correct answer is option 2, the structure of the solids. In optical fiber, light is being traveled over long distances. This is possible due to difference in gas between the fiber and the surrounding material. Option 1, index of refraction, option 2, reflection of light, option 3, huge gap, option 4, insulation. And the correct answer is option 1, index of refraction. When an electromagnetic wave reflected from the boundary of a denser medium, as it travels from rare to denser medium, it undergoes option 1, 90-degree phase change, option 2, 180-degree phase change, option 3, 270-degree phase change, option 4, no phase change. And the correct answer is option 2, 180-degree phase change. Remember that rare medium has less index of refraction as compared to denser medium. When an electromagnetic wave reflected from the boundary of a rare medium, as it travels from denser to rare medium, it undergoes 90-degree phase change, 180-degree, 270-degree, or no phase change. And the correct option in this case is option 4, no phase change. So remember that when a ray is reflected from the boundary of a rare medium, when it travels from denser to rare medium, there is no phase change. And if the electromagnetic wave is reflected from a denser medium, as it moves from rare to denser medium, it always gives us 180-degree phase change. Because the rare medium has less index of refraction and the denser medium has high index of refraction. فردر لیٹسٹ انفارمیشن کے لیے ایجوکیشن کیریئر کے حوالے سے، ایڈمیشنز کے حوالے سے، انٹری ٹیسٹ کی تیاری کے حوالے سے اور کسی بھی طرح کی لیٹسٹ انفارمیشن کے لیے آپ ہمارے چینل کے ساتھ ان ٹچ رہیں اور اس کو سبسکرائب کریں، بیل کے بٹن کو ضرور پریس کریں، دوستوں کے ساتھ شیئر کریں، اپنا خیال رکھیں، اللہ حافظ.